All right, in this brief video, I'm just going to solve a quick example problem that's going to probably help you on the homework. And so I'm just going to put example right here, and I'll just go ahead and make an example circuit. Let's just say I have a 9-volt voltage source, and then I have some resistance. So I could, up to this point, I could do either, I could write another ground here, or I could connect this over to this ground. And both of those are pretty equivalent. Sometimes, though, just to avoid drawing the other wire, you'll see something like this. So I'm just going to do that so that you get used to seeing it. And let's say that I have a 5 kilo ohm resistor right here. And in this problem, I want to determine what is my voltage VA, and I also want to determine what is the current IA flowing in my circuit. Okay, so the first thing I needed to do is determine VA, and the second thing I need to do is determine IA. All right, let me actually do the voltage in blue, just so that I like to keep my voltages in blue and my currents in red. Really helps me a lot when I'm solving problems to have these things color coded, so that when I'm looking at the circuit, if I see blue, I know I'm looking at voltages. If I see red, I know I'm looking at currents. So I'll do that sometimes. Sometimes I'll probably forget, but I do when I do my own homework and when I am solving problems. I like to do stuff like that. It just keeps it clear in my head. So let's separate this into kind of two parts here so that I can keep my work nice and clean. Okay, so the first thing I want to do is determine what is the voltage VA. Okay, so this is actually quite simple, given that we know, what do we know here? We know that the voltage, anytime I see a ground, the voltage on that net is 0 volts, right? So let me go get my highlighter. Sorry, I'm still getting used to using GoodNotes. So this net right here is 0 volts. And then I have another net right here, which is also ground, that's also at 0 volts. Right, so this is also 0 volts. And then the last net that I have in my circuit here is the VA net, basically this net right here. And that is at a voltage which we're labeling right now with the variable VA. And so we want to know what is VA, right? Well, we know that, again, the yellow nets are 0 volts. And then we also know that my voltage rating of my battery is 9 volts. And so what that rating tells me is it tells me that the plus side is 9 volts higher than the minus side. Oops, I don't want to write minus. Than the minus side. Okay, so if that's the case, if I'm at 0 volts here and I'm 9 volts higher on this side, then that means that this side has to be at 9 volts. And since we know that the voltage on the entire net is the same, then that means that VA is equal to 9 volts. All right, it's really just that simple for VA. So 9 volts for VA. And then I would go ahead and box my answer. All right, and I guess my work, I can just move my work for VA over to my little column here if I really wanted to, just to keep everything clean. I'm gonna drag the black line too. Yep, I already knew it. Sorry guys, I'm still learning GoodNotes. All right, so we said that the plus side is 9 volts higher than the minus side, and thus the plus side is at 9 volts. That's basically our reasoning for finding VA to be 9 volts. Okay, so now finding the current is a matter of just simply using Ohm's law. Again, we know Ohm's law tells us V is equal to I times R, where V is the voltage across R, and I is the current through R, right? Okay, so in this case, I know that across my resistor, I've got 9 volts here, and I have 0 volts here, right? Because I determined VA to be 9 volts, and I know that ground is 0. So that means that my voltage drop across my resistor is 9 minus 0, or 9, okay? So that becomes my V in this equation. And I know I'm trying to find IA, and I know that my R is just 5 kilo ohms. That's given, right? So if I want to determine IA, I can just divide both sides by 5 kilo ohms. And I'm going to go ahead and do that. And so then my IA is going to be equal to 9 volts divided by 5 kilo ohms, or 1.8 milliamps. You can do the math in your calculator to verify that that's correct. And so there you go. I've solved for IA and I've solved for VA. Sorry, I am a mess. 1.8 milliamps. Move this over a little bit. We'll box it. And I have solved for VA and IA in my circuit. And so now if I wanted to, I could take this whole thing and kind of put it into the column over here. I'm just going to erase this. We know that I is the current through the resistor. And then I can take this and throw it right here. All right. So that was first example. In the next video, I'll probably solve another one just to make sure that these concepts are clear. And yeah, all right, signing off on this video.